Hi, hello viewers. Welcome to today's episode. If you know you've not followed this page, make sure you do that at the end of this video. And let's quickly dive into this question here. Question talks about empirical formula and it's a very straightforward one. Let's learn together. The question reads: A compound contains 52.2% of carbon, 13.1% of hydrogen, and it also contains oxygen with an unknown percent, and the vapor density of that compound is 23. We are asked to do two things here. We are asked to calculate the empirical formula of that compound and also the molecular formula. First of all, empirical formula is a ratio formula. It might be the real formula or it might not be the real formula, but it's just the simplest way of representing that compound. While the molecular formula is actually the main or the actual formula of that compound. We are asked to use the following information to determine the empirical formula and the molecular formula. Now let's quickly dive into that. We are given that there are three elements present here: carbon, hydrogen, and oxygen. And we are given percentage. Remember that the mass number of carbon is 12, hydrogen is 1, and oxygen is 16. So let's give it to us in equation. Now, first of all, what is the percentage of carbon there? 52.2%. Hydrogen, 13.1%. 13.1%. And we are not given the percentage of oxygen, but we can quickly get that. We know percentage is all over 100, right? So meaning that all this is meant to be over 100. So what will be oxygen? Simply we add these two and subtract it from 100. So 52.2 plus 13.1, 13.1, that gives us 65.3. And you deduct 100 from that, simply gives us 34.7. So that's the percent of oxygen. Now, the second step, we have to calculate the number of mole. Number of mole is simply mass all over the atomic mass or percentage all over the atomic mass. Now, in this case, we are given the percentage of the elements involved, and the atomic mass of carbon is 12, hydrogen is 1, and oxygen is 16. So let's solve for the moles present here. We subtract this 52.2 divided by 12, and we got 4.35. That's the number of mole. And simply hydrogen still gives us 13.1. Now oxygen, if we do that, we get 2.17. So these are all the number of moles. The third step we have to do, we have to divide this number of moles by the least one. So we are going to see the ratio between the elements there. So look at this number, which of them is the least one there? We notice that 2.17 is the least. If we divide this, we get 1. 2.17, divide this and divide here by 2.17. So when you divide this, I think we get approximately 2 here. If we divide 13.1 divided by 7.2, 2.17, we simply get 6. So this is the ratio in this element, meaning that carbon here has 2, hydrogen has 6, and oxygen have 1. So this is the ratio formula. But this ratio formula can also be the actual formula. This empirical formula can also be the actual formula. We can't tell. Now let's use the information given to us. We are told that the vapor density of this particular compound is equal to 23, right? So we are correct. It's equal to 23. Now, what is the actual formula here? First of all, what is vapor density? Vapor density is half of the relative molecular mass. So whatever the relative molecular mass will be, vapor density is just the half of that particular compound. So if the vapor density is 23, meaning that the relative molecular mass will be equal to times 2 of this, which is 46. So let's see. Remember that we are asked a second thing to calculate for the empirical formula, the actual formula. Now let's see. Let's see if we sum the relative molecular mass of this compound, if this gives us 42. If it gives us 42, we know that this is a ratio formula and this is also the molecular formula. Let's simply do that. Carbon here is 12 appearing 2 times, plus hydrogen is 1 appearing 6 times, plus oxygen is 16. So if you do that, this 24 plus 6 plus 16, and this gives us 20, 30, 40 equal to 46. So this is the actual formula of this compound because the relative molecular mass or mass of the empirical formula matches the information given to us. So the formula of that compound is C2H6 and O. So this is the molecular formula and this is also the empirical formula of that compound. Have a nice day and see you in the next one.